What's going on, everybody? Hey, Justin here again. Today we're underneath a house and we're trying to troubleshoot to find out why some bedroom receptacles went off. We've been out here previously. We determined that it wasn't a weakening breaker, put a new breaker in, held for a little bit, and then the problem seemed to be persistent shortly afterwards. So we got underneath the house, start pulling insulation out the way. Let me show you a little bit about what we found out, why this bedroom and living room circuits have started having problems. Let me show you. So underneath mobile homes, usually between sections, they interconnect with these plug-in type devices, and they take the piece of non-metallic sheath cable and they just drop it out from a device above, and then they just quick connect plug, and they do that with one section to another of a double wide. Well, under here is the first device in the run. So after we determined that it wasn't a breaker issue, I crawled up underneath, come from one end all the way to the other, got up underneath the bedroom, and then started pulling insulation out of the way. Get another flashlight, and then saw a burn mark on the wood right here. And I'll put in a picture of what the cable looked like, but it had shorted to itself and eventually just burned a hole in itself with cable like this. So burned up a section about that size. But they are put together, like I said, from the devices, receptacles, switches, and stuff like that above, with these little interconnect devices. So two of these are good, and we're going to leave them as is, but the section that was burn up coming out, you can see that part right there, burn up, what's connected into here. This is coming directly from the panel, so I put some equipment on it, tone it out, come over here and identify this as the home run coming from the panel. This is really corroded up inside, so we're just going to do away with this one altogether. Put it in a box, get a box mounted up here on the structure, right up in here on the framing member, get it pulled out, replace that connector with a wire nutted splice, come over, hop back in, and then refeed this whole circuit, get everything back online. What's going on, everybody? Hey, hope you enjoyed our little adventure going underneath that home, talking about the burn up non-metallic sheath cable, Romex. I want to take this minute to kind of describe a little bit, show a little bit more of the products that were used, because it's not something that we typically see in the videos that I share, any kind of photos and images stuff. Usually we have a outlet box, has a device in it, wire nut connection, stuff of that nature, things contained within an enclosure of some sort. So this situation is a little different because the code allows, in the article, which is 334, is for non-metallic sheath cable. It talks about self-contained devices and self-contained interconnecting devices for that non-metallic sheath cable, Romex. So I kind of want to show you a little bit more about that. So these here, the first one we're going to show, this is a self-contained device, a receptacle. So usually this is in the wall. It's got these little wings, so whenever it tightens up, they flip up, you tighten the screw, it pulls it in, and it holds it on the sheetrock between the face and the back side of it, and it holds it to the wall. Instead of having a typical device box behind there, an outlet, we have this one where it's completely contained. So try to pop that open, and inside of here is a series of, I guess, knives is the best way to say it, and then you strip out the cable and you put the conductors into its proper spot for the hot, neutral, and the ground, and it pierces the insulation and making a connection to the conductors inside. So on the back side, removing this back piece, you can see I've got two cables, I cut them loose. So you got the hot here, the ground in the middle, and the neutral, and they correspond to this side, the hot, ground, neutral. Okay, so when you don't strip these out, you put them in there, you press them in, and then the blades will pierce the insulation, make contact with the copper conductor inside. Okay, so this is the one device. This is typically in mobile homes. You'll have switches, receptacles, single poles, and three-way switches, but that's what's inside of these here. The other thing that was underneath, so we had the piece of cable that burned and made the mark in the vapor barrier underneath. So this is what happened underneath. There was no nails or anything in that area that seemed like it would have damaged the sheathing on this. The only thing I can assume is maybe at time of install, there's a little damage, and then it turned out just couple feet away, there was a shower that had a leak underneath it, and there was a little bit of framing damage, and there's a lot of moisture underneath there. The only thing that I could figure is that maybe this was a compromised part in the insulation. The moisture got in there and then somehow began to arc between, focus on this, there we go, between the hot and the ground. The neutral still inside, white conductor. It didn't have any damage on it, but it did arc between here and here. There, it was stuck together. And then so that eventually is what was causing the problem originally whenever I went out there to see why this breaker was tripping. Max it ever pulls 4.5 amps, so it was really kind of an investigating means to find this little thing. These are two interconnect devices that are pressed together and they're locked in. It's got little secure tabs. It's very similar to that receptacle. It has spots here where you can do your, where we can do your hot, your ground, and your neutral. And then the other side is corresponding with it. And then they go, they push together, they clip, and they're in. So National Electrical Code allows these devices to be used. Previously editions, they were allowed in like a repair type deal after a structure has like essentially has a CO, after construction is complete. It happens, someone drills a hole in the wall, or a hole saw or whatever, goes through sheetrock, damages the cable, and then this is a way to repair it without having to re-pull to who knows where, especially if it's between floor levels where you don't have easy access. So this device is this particular one is rated for 15 amps, pretty much 14 gauge wire. And it does have a notation on here. You won't be able to see it, it's really damaged, but it says do not re-terminate. So these kind of one-time use. Once you make them, you pull them apart, you don't need to do them again, unless it's a new device. And I can only assume that these would be the same as well. So removing this device, I replaced it with a AFCI, arc fault circuit interrupter, receptacle type. And it looks very similar to a GFCI, like in your kitchens, bathrooms, outdoor receptacles. It's usually looking for a ground fault. Only the AFCI device, it is looking for arcing characteristics. So it's looking between in a parallel means, in other words, from conductor to conductor, whether it's hot to ground, hot to neutral. It's also looking for a series arc. So if you had your neutral was damaged and then the current flowing on it and then there's a little between it and it's arcing that jump, and it recognizes those characteristics between either the neutral in a series arc or the hot as well. And then so putting that in the first device location of that branch circuit, it left from the panel, came to that one location where this was, replaced it with a box and the AFCI device. That is now monitoring the rest of the circuit. So if, like this one here is corroded up. It actually had there's a lot of ants inside of it still cooked on the terminals there. But there was that one. There was another one that water had gotten to, really corroded the connections up. I believe this was starting to overheat here because this sheathing is usually pretty pliable and this part here's got rather stiff. So those devices are for those applications. You're going to find that a lot in a mobile home, manufactured homes and stuff of that nature. And then, like I said in the video, where the locations of where these usually are, underneath at the joining parts where the two units come together, and the same part where it's like a 2x6 is run between at the top of the ceiling. A lot of times you can pull that down and find a handful of these in there as well, and that may be the source of flickering lights, receptacles not working properly. Go plug something in and it goes on and off. And so this is kind of a better description, not being underneath there, a little controlled environment as to what was going on and the repairs that were made. Like I said, the AFCI, if this ever happens again, it's going to see it. It's going to recognize the arcing characteristics, whether it's parallel or series. It's going to shut it off, and then we're going to know if there's a need to start cutting out more vapor barrier and look for any more potential hazards. And hopefully this is just a one-off thing because of the shower leak that was right there in the vicinity and caused the damage. Anyways, so this is it. This is a little better shot of it, and everybody have a great rest of your day.